So in this video, we will look at the MCQs related to kinetic model of matter. Question number 1, when a gas has a fixed volume and you heat it, its molecules get kinetic energy and starts moving faster. Question number 2, a fridge, when it's switched on, what happens? So we know that it is a cooling unit, so it will decrease the kinetic energy and they will vibrate less vigorously, so they will come closer, and that will cause the air closer to the cooling unit decrease its volume, and the decrease in volume will increase the density. So D choice. This question is asking about when a solid is melting, what happens? So this is a solid, but this is not. When a solid melts, it becomes liquid. This is becoming gas. These two are liquids. So A choice. When the solid is melting, it changes into liquid. And we know this from the arrangement of the molecules in a solid and in a liquid. So question number 4. Well, when a gas is cooled down, its molecule will vibrate less. So they will move more slowly. We know this from the kinetic model of the matter. So even when the liquid is cold, still evaporation takes place, and that is why the name of the process is evaporation. So the particles of the gas increase its pressure by increasing their collision. So they collide the container more frequently, and that increases their collision. So the molecules that leave always have high energy than the rest of the molecules of the liquid. And molecules that are left behind have greater energy before evaporation. Question number 8. So when you increase the pressure and the temperature does not change, then what happens? So if you keep the temperature constant, the molecules with the same kinetic energy will now have less space. The volume will be decreased. Now they will hit the walls more because the same number of molecules, less space, and having the same energy. So their collisions will increase. They will hit the piston more frequently. Question number 9. When we heat the flask, the oil drop rises. Well, let's look at these 3 options, why they are not correct. The air molecules hit the container with greater force? No. The air molecules move faster? No. The air molecules move further apart? No. They're all correct. So only this one is wrong. The molecules get larger. That is not possible. Question number 10. So, large surface area gives more evaporation, and higher temperature also causes more evaporation. So B is the correct choice. Question number 11. The shape of and volume of the liquid. The shape is fixed. So I think we got the wrong choice here. Yeah, that's not correct. So the shape of the liquid is not fixed, but its volume is fixed. Will be choice C. Why? Because liquid changes its shape according to the container, but its volume does not increase or decrease. The gas does not have a fixed shape and does not have a fixed volume. Question number 12. Well, the pressure of the gas increases upon heating is because the molecules move fast, and this movement makes them to collide with the walls of the container more frequently. When a gas changes into liquid, the molecules will come closer, become clusters, and by doing so, they will lose energy. Question number 14. Well, when the person comes out of a warm swimming pool, his temperature is high, and then it's a hot summer day, evaporation takes place, and the water takes heat from the body. The water at the water on his body when he was in swimming pool, it has taken the heat from the body. Now, when it evaporates, the body cools down. Question number 15. The shape and the volume both not fixed for a gas. Question number 16. So when a temperature is raised for a gas and the pressure is constant, the volume will increase, and that will make the gas move further apart. But when the temperature is increased, the pressure is constant. When the pressure is constant means the volume will be allowed to expand. When the volume expands, when the volume increases, this gives the molecule more space so they move apart. Question number 17. So when we have a fixed volume and we heat air, the pressure of air increases. Why? Because the molecules bounce off the walls more quickly. This is because when we have a fixed volume, the molecules, although they want to expand the container, but the volume is fixed, so they do not find enough room, but they get more energy due to the temperature increase, so they start bouncing or colliding with the walls more frequently. Question number 18. The more energetic molecules leave, it is called evaporation. Question number 19. When a gas having a fixed volume gets energy from external source, the molecules of the gas will move faster inside the container. So in this question, piston is moved, volume increased. So when the volume is increased and we keep the temperature constant, the pressure has to decrease because they're both inversely proportional at constant temperature. And the reason for this, although it's not the reason that the pressure and volume are inversely proportional, the reason is the molecules collide less frequently because they have more space and we have kept the temperature constant. So molecules have the same energy when the temperature is constant, but they have more space. So their collisions due to more space will decrease. So question number 21. If you have a melting point -17, -10 is greater than -17. So the substance will be a liquid. And 110, it will still be a liquid because it boils at 117. 22, when you compress a gas, the temperature increases because the molecules, upon having a less volume, will move closer. So that will increase their average speed or average kinetic energy, and due to which average speed will increase. Question 23. Why is the drink kept cool under this arrangement? Wet cloth and a dish of water. They're both causing evaporation, and the evaporation causes cooling. So water is evaporating, cools the drink. Number 24. Well, liquid state, the forces between particles are strong and their motion, they vibrate, they they are free to move as well. They vibrate because they are in clusters and the clusters can move about during the liquid. They do not move randomly like in gas. This is the gas. We have a weak force and we have a random movement at a very high speed. 25. So when we heat a balloon, the mass does not change, but the density will decrease because the volume will increase. 26. Why a liquid has a fixed volume but not fixed shape? It's because the force between the molecules is large. So this large force means that they are still with each other, they stay with each other. So they have a fixed volume. They do not occupy all available space, but their movement, they move throughout the liquid. So they go in a different container, they move, and the liquids tend to keep their shape as well. So that's why their shape is not fixed. 27. how does the temperature of a liquid that is allowed to evaporate change? Well, its temperature will decrease. It is because the energetic molecules are allowed to leave the surface and less energy. The energy of the liquid goes away. It is cool. It is cooler now. 28. Well, when evaporation takes place, most energetic molecules leave the liquid. That's why it cools down. When a metal bar is heated, the distance between the molecules increases, making the bar longer. It is because they vibrate with more amplitude. 30. The molecules, how do they strike when a gas is compressed at constant temperature? The temperature is not allowed to increase, so the less volume will mean more collision, but with the same velocity. Same velocity means no change in temperature. More collisions means less volume, less space, same number of molecules. That's why. 31. F does not change, and so if F does not change and the temperature is increased, it will increase the volume. That is simple because at constant pressure, the volume and temperature are not, the volume and temperature are directly. 32. The rate of evaporation here, if we keep everything constant, the temperature, the wind direction, the rate of the evaporation will decrease. Why? Because of the surface area. Every time the evaporation will take place, the puddle height will go down, so it will have less area. Less area means less evaporation. 33. So these three factors can be played with. How many of the changes would affect the rate of evaporation? So the depth of the water has nothing to do with evaporation. The surface area and temperature will. So two factors. 34. Thermal expansion. So this is the data and this is how the strips are made. We have metal X and Y. Metal X expands more than metal Y. Okay, so look at this. Aluminium, highest expansion, copper, less than aluminium, platinum this, and steel this. So we have to look at the combination. Could this be aluminium and platinum? Yes, possible because aluminium expands more than platinum. To be honest, everything with aluminium should be the first consideration. And then aluminium here does not make any sense because aluminium will expand more. In here, steel and copper. So look at the steel. Steel and copper. Copper has more expansion than steel, so copper can't be in Y place. And the last one, platinum and steel. So the platinum has less expansion than steel, so it can't be in Y place. Platinum has less expansion, so it can't be in X place. So aluminium and platinum. Aluminum having more tension at the same temperature than platinum. So these two will combine and make a strip after heating that will bend this way. The incorrect statement for a liquid to get heat is again molecules do not expand. Everything else seems correct. Molecules gain energy, yes. Move faster, yes. Move faster. Move further apart, yes. The molecular structure of a liquid, well, the distance is close. It's not far apart, so C and D gone. Now, molecules are stationary? No, they are in random motion. And the strength is not very strong, it is fairly strong. So first two should help you to decide. It will be B. Well, the weakest forces are in stream. It's not ice, so reject AB. And then stronger steam, and then water, and then ice. That makes a perfect solid, liquid, gas stream. So C is the correct choice. What name of the process again? Evaporation. 39. Well, this is a liquid because moving past each other and closer together means a liquid. It can't be solid, reject C and D. It can't be gas because they're not moving passing each other and they're not close together. Number 40. Both liquid and gases can flow. Solids cannot flow. The A and B, the liquid do not fill the container, and liquids are incompressible, and sorry, the gases are not incompressible, and the molecules of liquid are in fixed position. No. Gas fixed position. No. The both wrong. 41. Temperature has to be high, surface area has to be large to get maximum possible evaporation. 42. Rate of evaporation will increase if you increase the temperature, increase the surface area, increasing depth does not. All three yes, reject. Increasing surface area, no, rejected. Increasing temperature, no, rejected. Only this. So again, the depth of the liquid will not affect its evaporation. So it is again, the average speed is gradually increasing. That means the liquid is being heated. And the particles close together and moving past each other, that is a characteristic of a liquid kinetic model. 45. So the student squeezes and warms each bag. Which bag contains gas? So first of all, look at A. The one that changes shape easily, okay, and expands the least when heated. No. Look at C, the one that is fixed. No. The one that is fixed. No. So reject all three of them. Look at B now. The one that changes shape easily. Yes. And expands the most. Yes. So this is a gas. 46. It is repeated, but with a different statement. The water takes latent heat from his body in order to evaporate. Look at A, C, and D. Water allows a convection current? No, it's not flowing on his body. The water on the skin is a good conductor of it. Water is not a good conductor. The water prevents IR? No, it can't. You